Welcome to CTS Group and this training module on gas rates and heat input for domestic gas. This is an audio-visual module, so make sure you have your speakers turned up or headphones on. When you have completed this module, you'll be able to calculate the gas rate of an appliance in British thermal units and kilowatts using both metric and imperial gas meters, and to correctly compare the actual gas rate with that required by the manufacturer. Where a person performs work on a gas appliance, he or she should immediately thereafter examine the effectiveness of the flue, the supply of combustion air, its operating pressure or heat input, or where necessary both, and the operation of the appliance and its safety devices. In this case, we're going to look at gas rates and heat input. The reason you need to check the operating pressure or heat input is to ensure that the appliance pressure is set to the manufacturer's technical information and that the appliance is burning the correct amount of gas as stated in the manufacturer's technical manual. This is what you need to calculate the heat input of an appliance. Something to write with, a calculator, something to write on, and finally a stopwatch. Let's take a look at some definitions. First of all, heat input equals gas rate times the calorific value. Gas rate is the volume of gas consumed by an appliance in an hour. Calorific value is the amount of energy in a stated volume of gas. For example, for every meter cubed of gas, you get 10.76 kilowatts. And for every foot cubed of gas, you get 1,040 British thermal units. Let's take a look at calculating the heat input of a gas-burning appliance. This example will be carried out using a U6 metric meter, which measures in meters cubed per hour. The first thing to do is to fire up the appliance to its maximum setting, and don't forget to turn everything else off first. Now go to the meter and make a note of the meter reading as you start your stopwatch. At exactly 2 minutes, note the new meter reading and write it down. The next thing is to subtract the start number from the finish number, and to make it easier, we'll shift the numbers around. So we are subtracting the smaller number from the larger number, which is the start reading, from the end reading. So, time to use your calculator. 2.252 minus 2.89 equals what? Of course, 0.063 meters cubed. So now you know that the gas appliance is burning 0.063 meters cubed every 2 minutes. But what you have to work out is how much gas the appliance is burning in 1 hour. And this is how it's done. To get the volume of gas burnt in 1 hour, you multiply the 2-minute total by 30, as you can see by the sum here, giving you a result of 1.89 meters cubed per hour. The next thing you have to do is calculate the heat input of the appliance. This is done by multiplying the volume of gas consumed in 1 hour by the calorific value of gas. Natural gas has a calorific value of 10.76 kilowatts per metre. Looking at our result, that gives us a heat input of 20.33 kilowatts per hour gross. So from the result, we know that the appliance has a heat input of 20.33 kilowatts per hour. So a quick summary of that calculation. Firstly, we subtract the start reading from the end reading, and that gives us the amount of gas used in 2 minutes. We then multiply that result by 30 to get the amount of gas used in an hour. And then we multiply that by the calorific value of natural gas, 10.76, that will give us the heat input in kilowatts per hour. And here's the completed sum. Remember though, the heat input you've worked out here is gross. If the heat input shown on the data plate is a net figure, you'll have to convert this gross figure to a net figure by dividing by 1.11. Of course, you'll be very pleased to hear that there is a much simpler way to calculate gas rates. Instead of fiddling about with all those calculations, a much easier way is to simply check your reading against your gas rate charts. Here's one to practice on now. Remember, we had a reading of 0.063. To work out the heat input from the chart, all you have to do is look down the column headed 2 minutes gas flow until you find the same number. Then read across your chart until you find the equivalent heat input in kilowatts, both gross and net. And now, just when you thought you knew it all, we're going to move on to British thermal units, or BTUs as they're known. There are still a lot of gas meters out there which measure the gas in cubic feet. And there are many appliances still in use which are rated in BTUs. So you need to know how to work out the heat input in British thermal units. This is not so difficult. Suppose you're working out the gas rate on a metric gas meter, but the appliance is rated in British thermal units. First work out the heat input in kilowatts, then simply multiply by 3,412 to give you the heat input in BTUs. Here are a couple to have a go at. Convert these kilowatts to BTUs. So it might be an idea to pause here while you work out the calculation. 35.17 times our variable 3412 gives us 120,000 BTUs. Let's see if you got the other two right. If you have to work out the BTU rating of an appliance from a cubic foot meter, here's how you do it. Using your stopwatch, record the time taken for one complete revolution on the dial. This will give you the number of seconds for 1 cubic foot. Now we have to work out how many cubic feet the appliance will burn in an hour. Let's ask ourselves, first of all, how many seconds are there in an hour? Well, of course, there are 60 seconds in a minute and 60 minutes in an hour. So multiply 60 by 60 to get the seconds in an hour, and as you can see, it's 3,600. So to work out the amount of cubic feet consumed by the boiler in 1 hour, all you have to do is divide 3,600 by the amount of seconds taken for 1 cubic foot. And here you can see the sum. You now know that your appliance is burning 69.2 feet cubed per hour. And finally, to get the heat input of the appliance, multiply the cubic feet consumed in 1 hour by the CV of gas, which is 1,040 BTUs per cubic foot. And here's our sum. Of course, there is a simpler way. You can use the BTU gas rate chart, which you'll find in your workbook or field guide. Once you know how many seconds it takes for 1 cubic foot, all you have to do is look for that number in the seconds to burn 1 cubic foot column. Suppose it takes 74 seconds for 1 cubic foot. You look for 74 on your chart. And then you read the columns to the right to get the gas rate in BTUs and kilowatts gross. So now that you're an expert on calculating gas rates, you can learn how to put this knowledge into practice. Once you have the actual heat input of an appliance, what do you do with the information? Well, the first thing is to check that the actual heat input matches the manufacturer's stated heat input on the data plate or in the manufacturer's instructions. And then, if the actual input and the input required by the manufacturer are different, calculate the percentage difference. If the actual input is within plus or minus 5% of the required input, the actual heat input is acceptable. Outside these limits, it's unacceptable and you'll have to take action to rectify. Calculating the percentage difference between the actual and required heat inputs. The formula is as follows. We take the actual heat input, we divide it by the required input, we times it by 100 and minus 100. Let's say that you've calculated the actual heat input of an appliance to be 12.5 kilowatts gross. You look on the data badge and find that it should be 14 kilowatts. Using the formula provided, calculating the result, we can see that the appliance is undergassed by 11%. Is that acceptable? No, because the acceptable range is plus or minus 5% unless the manufacturer states otherwise. This appliance is 11% under, which is well outside the acceptable range. Now it's your turn to have a go. Work out these percentages and state whether they are acceptable or not. You can pause at any time. Using the calculation, we can see that it's 2.86% over. And that is of course acceptable. Now do the next one and pause before moving on. If you've done your sums right, you'll see that this one is 11.6% under. And of course, that's not acceptable unless the manufacturer states otherwise. Now take a note of the last calculation, pause, calculate for yourself, and then continue to see if your answer is correct. On this last example, we can see that we're 4% over. And that is within the acceptable limits. Thank you for taking this training module on gas rates and heat input.